All right. So, hope you all still have a little bit of energy. I know it's a long day, and there have been a lot of great talks, but I will try to make this a little bit entertaining and some energy, so hopefully you'll stay with me. All right, let's start maybe with a quick intro of myself. So, my name is Marcel, and most of you, an Android developer. I've been working on Android for more than a decade, and I was part of the Android DevRel team at Google. But this year took a different path, and I'm trying my own app studio, trying to build apps and specifically focus on AI. Basically, I'm having fun right now, but we will see where that goes. All right, so today I want to share a little bit about this journey and how did I integrate AI in my Android app. I learned the bad way, the ugly, and the good one, and I want to share with you today about that. So, artificial intelligence, fancy image, right? Obviously generated with AI. So I'm not going to go really deep into what is AI and so on. I'm by far no expert on this subject, right? But this talk I'm going to concentrate on a part of AI that is generative AI, and specifically how you can integrate that into your applications. So, what is generative AI? Basically, it's a technique, right, that learns from data, from existing artifacts, and generates new artifacts. Everything is based on a foundation model. Those are a class of models that they are pre-trained on vast data across various domains, enabling them to develop a wide range of capabilities, not only limited to text, but as well images, sound, and so on, right? Then, on top of this, they are the large language models, or LLM. Those are models that they are notable for their ability on general purpose language generation or classification, natural language, and so on. You probably heard about those. ChatGPT 3.5, the 4, the Llama, the Mistral, that is from a French startup. And then on top of all these is where we have the chatbots, the user interfaces, and API, and Android apps, right? So this is super generic, but I'm not going to focus on that part. What I want to show you now is that this technology has opened a new possibility, right? We can reimagine existing use cases and find new ones with AI. And I'm sure that a lot of you tried that when it came out, right? Who tried already the ChatGPT or the Gemini on their applications? Raise hands. Yeah. So you're probably familiar with this graph. So there's no doubt that there is a hype about AI, right? And to be honest, I think we have not reached that peak yet. So we still need to find what is the benefit of AI and how to integrate it. We have rushed into just try to put AI everywhere, right? And all the big companies are doing. I think we still need to go through this and find the real value of AI and how it can be integrated in the apps and benefit the users. But for today, I want to just dive in and jump into this hype and create our own application. So I have an idea. It's really great. So let's build an app that's taken any message from social or from messengers and so on. You share it with the app, right? Then I use AI and I generate an awesome reply based on the tone, the format, and so on. I copy it to the clipboard, and the user can reply directly. I'm going to make millions out of that. I'm super sure about that. All right. Let's first check the docs. Basic thing. So I'm going to use the Gemini SDK for this. First of all, we need to get the API key. That's easy. Unless you're in Europe, then you need a VPN, and then, yeah. Anyway, let's not get there. Next, we need to take the key that we generated on the Gemini console and put it in our code. The docs are telling us that we can use the build config and Gradle and so on. I rather would say this is hard coding the key, but let's get into this later on. So now, we just need to create the client. The Gemini SDK is pretty simple. You just pass the model you want to use. For this use case, probably the Gemini Pro is good enough. We pass the key that is on our build config, and then we just can use the SDK, right? We just call generate content, and we get our prompt. We get our response, and that's it. Seems pretty straightforward. So let's take a look at the code. Don't judge it. It's a simplification. So first, we get our source text that the user shared with us from the intent, right, that was shared through our app. And then we get the clipboard manager, and we create the Gemini model as you saw before. We say that we want to use the Gemini Pro, and we pass the API key. Then after that, let's become a prompt engineer, and we are going to make our awesome prompt to get a nice reply from the Gemini SDK with basically asking to give a funny reply based on what the user input. We get the results, and we put it into our clipboard. That's it. That's pretty much it. The user then can go back to the application and paste the content of this. I'm skipping the UI, by the way. So yeah, we shared with our app. We generate the reply. We copy to the clipboard. And that's it. I can paste it and reply right away. I think it's ready to ship it, right? Shall we ship it? Yeah? Come on, a bit of energy. Shall we ship it? Yes, let's ship it. All right. So the next day come, and I start to check out the AI cost. I'm a bit afraid of them, and oops. Yeah. So what happened here? The API key was stolen, right? So how? Yeah, it was hard-coded in our code, right? You just download the APK, you use Understudio itself, or there are other plenty of static analyzer tools that can take your code and find the key right there. Build config, show big code, my API key. Yup. So yeah, it's as simple as that. And now you will say, oh, obfuscation. Yeah, that will not solve it either. So I present you the bad way of implementing AI on Android. Let's improve that. So there are a few things that we could apply here, right, to try to avoid anyone stealing our API keys. Obfuscation, right? That's the most obvious one. Actually, I think by default, if you release an Android application, it already applies the basic rules of ProWord and Errate and so on. So it will obfuscate the classes, the variable names, but it does not obfuscate the content of the strings. And remember, we just store it in our build config. That is a plain string. So the key will be intact there. All right. Let's apply some sort of obfuscation to the string itself. We can use as simple as base64, right? We encode our API key on base64, and then we store it in our source code, or apply some other custom logic, a bit more advanced. But in order to then take the key and pass it to the Gemini SDK, we need to revert whatever obfuscation we did on our source code. So for example, decode the base64. What that means is that all this logic that you are applying is on your source code. If anyone gets your APK, they can decompile it, reverse engineer, see the code, the logic that you put there, and just do the same as you did to get the key again. There are other techniques, right? You can put everything on a C file, compile it as a library, and that makes it a little bit harder. You put the key there, the logic, and you retrieve it. Still not good. There are some paying solutions that can perform certain obfuscation and make it more harder for your code, but they are pricey and I'm a bit stingy, so I don't want to pay them. So what can we do? All right, encryption, that's a possibility. So we encrypt our API key from the Gemini SDK, and then, but then I need to store the public key that I used to encrypt it in our source code, because otherwise how I'm going to decrypt it, right? So we are back to square zero. Anyone could find the public key on our source code and decrypt it. So we need here one more layer, and this is a remote server. So we should fetch the API key from our remote server. We can still use encryption, right, to add this extra layer. So we encrypt our Gemini API key, we store it in our server, then we take the public key and we store it in our source code. Then the user, the first time they open the app, we just go to our server, get the key, decrypt it, boom. Sounds good enough. Let's ship it again? Yeah? All right. Let's see. So yeah, that day was bad, but I think I managed to fix it. Not again. I present you the ugly way of implementing AI on Android. So again, what happened? API key was stolen, and so one is using it in our benefit. So what can we do here? So what happened exactly? Well, you know, we are fetching the key, but someone could as well get the public key for encrypting, find the endpoint that we are calling to get our Gemini SDK key, and just put the pieces together, right? And that's it. There is no protection, so anyone could fetch this endpoint, and yeah, we are back to paying a lot. So how can we prevent this? We need to add another layer, that is authentication, right? So this new layer basically will ensure that anyone trying to fetch our API key from the remote is a legit user or at least a legit device. And we are not passing our key to anyone that could be attacking us. So a possible flow here, basically you encrypt your API key, right? You obfuscate it in your source code. You authenticate the user, right? When it starts the application, and then you fetch into the remote, returning the encrypted API key, and then you just decrypt it at runtime and pass it to the Gemini SDK. So, a way to do it, again, using simple obfuscation that it's already available for you with the ProWord, right? Then you could use any algorithm to encrypt your Gemini SDK key. And then in the code, you could use the Jetpack Security Crypto library that will allow you to easily decrypt it and so on. There are plenty of authentication services there. Firebase authentication is one that it's probably easy to use. You could as well use then Firebase Remote or Firestore that works really nice with Firebase authentication. You can set rules like only let request read if it's authentication and so on, right? But there's still an issue. So you remember that, right? What if this gentleman goes into the middle? It could, what you probably heard, the man in the middle attack, right? So it could still find a way to really store, to really steal that. There are ways to protect, right? That there's a secure communication with the server and that doesn't happen. But what if this gentleman is in the device itself, right? There are programs out there that they can debug your code and add breakpoints at runtime to see what is on the memory of your application. So here's an example. This is IDA Pro. There are other software. They are called Frida, Mob SF, and so on. So basically, those programs, they are able to disassemble your code, analyze this disassemblement, and then get information about functions, memory usage, and other low-level details. In this example, for example, I added a breakpoint into my variable, and I can see what is on memory. So even if we went through all these steps, right, to protect our API key, someone with really bad intentions could still find that and get it on the memory. So it's not even stored locally. It's not even stored anywhere. It's stored on the memory when you get it from the server, and they can still get it. So what can we do to avoid executing our app in a device that is not trusted? So app check. Couldn't explain better to the video, so just gonna go for that.
Lots is happening under the hood. For example, this game is saving all its game state to Cloud Firestore. This app is using the Google Maps
Shit. Sorry.
When users use your app, lots is happening under the hood. For example, this game is saving all its game state to Cloud Firestore. This app is using the Google Maps API to help someone navigate home. And this app is calling APIs on its own server. All those services on the internet waiting for any request that comes in. But that means it's also possible for someone who's not using your app to try to make requests to those backends. How can we prevent people who are not using your legitimate app from accessing your backend services? After all, usage costs money, and no one wants to pay for illegitimate usage. This is where app check comes in. App check will block traffic that comes from sources other than your app. If you have have security rules, AppCheck blocks the traffic before it even gets to your security rules. To use AppCheck, all you have to do is register your app in the Firebase console, and then start enforcing that traffic that doesn't pass will be blocked. For this to work, AppCheck needs to be able to check that a request comes from your genuine app, not from some stranger trying to snoop around. AppCheck does this by using something called attestation services. These already exist for iOS and Android and the web. You can even build your own attestation services if you need to. AppCheck wraps all these services and makes them easy to use with our own SDKs. Now you can protect yourself and your app from anyone who might want to poke around at your app's backend. Firebase AppCheck can protect 3 different kinds of backends. Firebase backends, like Cloud Firestore, the real-time database, or cloud storage for Firebase. Google API services like Cloud Run or Apigee, and your API endpoints on your own server. Check out AppCheck today.
All right. So after this awesome promo, I'm by no means entitled to Firebase or anything. There are other ways to do that. I think AppCheck just is nicely because it combines with iOS and Android and web. But you can do this. You can use this attestation service without with AppCheck. But here the key point is that we can add this certain attestation in the middle, and it's going to block any request that comes from a legitimate device. So most of these apps, most of these programs I show you, like IDA and so on, they would need a device that it's either rooted, or they will have to modify your app. So they will have to do some modification that is most likely not going to pass the AppCheck. So meaning that whatever the application is trying to make a request to get your API key, it's just going to reject it. Although in security, nothing is safe, right? So there probably are ways that still can manage to pass this. So actually, a better way is to implement what is called a proxy server. So it's basically moving all your usage of the Gemini SDK or any AI and so on that you want to use and move it into a server. From there, you can still use some sort of AppCheck, right, to not allow anyone to use your server, but there is where you store your API key. And there are plenty of services out there for the server side to securely store your keys and that it cannot be retrieved. On top of this, it offers a lot, right, that you can then contact either OpenAI or Gemini based on different, if one is down on the other and so on. A great thing that combines with AppCheck is Fire function, is what I use on my case. It is really good because you can ensure that, for example, that the user is authenticate or that the user is a premium user, right? And then you allow it to use the SDK or not. You can use the AppCheck. You can control the prompt as well. So instead of passing the prompt from the client itself to the server, just let the client pass the parameters that you need, and then you do the prompting in the server side. There you can modify it, and you can update it right away without having to go through app reviews and so on. You can as well do some pre-processing or post-processing, right? So, for example, when you get the reply from the AI service, you could store it on Firestore and let the user retrieve the reply in any moment. It's already there on the base. So it allows you to do all this logic there, and then as well is way more protected. To implement it is actually pretty simple. First, you need to go through a bit of like the setting up the Firebase project, registering the app attestation for Android or for iOS or web, depends on what you want to use. But then on the code side, it's as simple as just installing the AppCheck. Right, it's just this piece of code, and this will automatically work together with any other Firebase service that you use, from Firestore, from remote config, or functions. In our case, we want to use functions that basically we are just going to call our function to generate and pass the source text of the user that has shared with our app. Then this will call our function on the Firebase function, and AppCheck here will be activated and will reject if it's not a valid device, if it's not a valid user, and so on. Although note that you have to explicitly say it on the function itself on Firebase. And then you can add your logic, right? For example, I want to check that it's an authenticated user in order to use this function. Here we could as well access this auth object, and will contain information about if it's a paid user or if it has enough tokens. And you could do these checks here, not on the client where it can be modified. On top of that, then we can do some verification on the content we get. Maybe we can check that it's not trying to inject weird words or and so on, right? So we can do all this logic here. And finally, just generate the reply. And here is where you can have your own logic of, I don't know, I call Gemini. If it fails, I go and call OpenAI, or there are like plenty of other services. You do some post-processing here and so on. I will not go into the details of all that for now. Yeah, so just quickly I want to show as well that on the server side, there are plenty of tools that are available for you as well to do some more AI engineering. I know it sounds fancy, but there are like some tools that allows for example, this is Instructor. You can basically switch between different models with the same SDK, and it allows you to have type safety, where you pass a data class to the instructor, and the reply of either Gemini or any model you're going to use is going to be mapped directly to your data class. So you don't have to do all the JSON deserialization, trying to tell ChatGPT, reply in JSON. I told you to reply in JSON. Give me this JSON, right? So all these things that you have to do a lot, and it has some as well retry mechanism. There are even more advanced tools. This is Marvin, where it provides a kind of a huge toolkit of things you can do on AI on Python. One of them that I like a lot is called Marvin functions. So basically, you are just defining the construct of the function, right? The name, what the input is, and what is the output. And then you just write the Java doc of it, and Marvin will create you the function for it. And you don't need to write any more code. It's just going to automatically then pass this to the models that you define and so on. So in this case, right, you just call sentiment, you pass a text, and it gives you a float of what is if it's a positive or negative sentiment, just with the prompt that you wrote on the documentation there. So there are many tools that unfortunately are not available on Android. So there is a huge benefit of moving all this logic into your server side. Some of them are available, but there are a lot of them that might not even be possible to have them. In any case, we get the result, we pass it to our function, and here you can just use it and copy to a clipboard, and now we have a happy user and our key secure. So are we ready to ship it again? Yeah? All right. Choo. Okay. Please, please, I cannot pay more. Let's see. Okay. Yes, I think we managed. All right. I present you the good way of implementing AI on Android. So, in a nutshell, these are three main ways, right? From the good way, where you are trying to obfuscate, encrypt, do this authentication, and having your key stored on the remote in order to protect that your key is being leaked and is being then used on your account. You can as well then move all that into a server, right? So there is the client just calls the functions, and all the logic for AI and calling the different services is on the server. This is the preferred way, but I will go into this in a bit. And then you have the bad way, that basically you are just putting the key into your source code and wish for the best. And the ugly, or probably, like the not so bad, right? That would be like to at least put the key into your server side or somewhere remotely that you fetch at runtime, so it's a bit more hard to get it. So, should you always use this good way? Well, no. There might be reasons for any of these, even the bad. but it's important to know the consequences of it, right? So on the good way, especially if you bring everything to the server side, the key is never on the client, right? So it's really hard to get the key. It avoids unauthorized usage. You can change the prompts easily. You can use advanced tools on the server side to do all that server logic and so on. But of course, there is a downside of it. You're increasing the time. Communicating directly with the Gemini SDK or OpenAI on the client is faster than if you have to go through a hoop of going into a proxy and so on. So you need to play with that as well. It will get more costly. Oops. Yes, we're back. So it can get more costly, of course. Firebase has, like, for example, a nice free tier, but it can go up on price. There, you can implement your own servers and so on, so maybe it gets a bit cheaper, but yeah. As well, there is a feature, for example, on the Gemini SDK is implemented, where you can stream the response of the AI, so you get like token by token, right, instead of just waiting for the full reply. Implementing this when you use this server as a proxy, it's possible, you can use WebSockets or stuff like this, but it will be a bit more hard. Then the bad way, sure, if you are building a prototype or you have a close group of people and you're not distributing these through the public channels like Google Play and so on, I think it's easy to start as well, and you don't want to go so complicated. But just be aware that it's really easy to hack, and anyone can get it. And it happened, so it doesn't happen to me, luckily, but it does happen that the keys are stolen. Same for the web or iOS. It applies for all these clients. Or the ugly way, right? Here the benefit is that you still have this direct communication from the client to the Gemini SDK or OpenAI without having to go through these hoops. And you can still update the API key in case it gets leaked, because it's stored on your remote server, so you could then create a new one and the clients will keep working. Because with the bad way, by the way, if you need to update your leaked API key, it might take like several days, so you most likely have to revoke the key and then wait for the Play Store review to happen before you can actually push any review. And we all know how long it can take. Of course, there is like an increase of cost as well, because you still need to have a server, but sometimes it can be more cheaper and can be super simple server just to store the key. There are like services there. So yeah, these are some of the pros and cons of these different ways. All right, so here just some recommendations based on my experience. First of all, always use AppCheck or some sort of attestation mechanism. Always make sure that your app is running on a trusted device and it has not been modified of some sort. There are services out there. AppCheck, I find it is easy to implement, but again, like, you can use others. Do not store the key in the version control. I think that's one-on-one. Like, use it if you store it. If you have it on the Android app, store it on the local properties, or use some sort of user a key management service, because, for example, you might want to share with different teammates, right? On the server side, there are plenty of services, but on the client side, there are as well other services. I would say prefer proxy server to local keys. You will have much more control of your security. You much more have control about all the logic and so on. But if speed is a factor on your application when you want to introduce AI, yeah, then probably not the best option. In any case, if you go on the way to get the key from the server and put it into your application, do not store it on the local on the share preferences or something like this. And if you do it, at least encrypt it, but still is like probably a bad idea. Instead, use some sort of technologies that they are in the different clients. On Android, there's something called Key Store that allows you to import encrypted keys from your server directly into a secure hardware that is available on the Android devices after API 26 or something like that. I don't remember, but The good thing here is that this transmission between the server and the secured hardware, the key will not be in memory. So even if someone tries to use these programs, it will not find the key there. So it's a bit complicated to implement, but you can use these things there. And set a hard limit. Most of the AI services, they allow you to set a limit on what's the cost. So if it's possible, use it as a precaution. You probably know how many users you're going to have at the beginning. So just set hard limits to avoid high bills. All right, so some last words. I think there's no silver bullet, right? And in terms of security, and this talk actually could be probably renamed to the hard, the easy, and the not so easy. So be cautious on that, right? There is no single solution that can fix all vulnerabilities. Okay, whatever. It's just a matter of adding layers and making it harder. So the bad actor says, okay, it's not worth it. I'm going to the next app that has just stored it as a plain text in the source code. And that's pretty much it. Thanks for listening. You can follow me, or you can check one of my last apps about generating baby names with AI. Thank you.